Chapter 4. Hand movements and spatial reference in shapes and small-scale space. This chapter focuses on how hand and finger movements contribute to spatial perception, particularly in small-scale environments like tabletop spaces. It examines the role of touch and movement in encoding and interpreting spatial information, exploring the use of body-centered and external reference cues in these tasks. The chapter also discusses differences in spatial processing between the left and right hands and the implications for tasks requiring fine motor skills. Key themes. Finger movements and coding Braille. Characters as shapes. Touch perception is enhanced by active exploration rather than passive contact. Braille reading serves as an example of how finger movements play a critical role in spatial coding. Scanning movements allow for the recognition of spatial patterns in Braille characters. The accuracy of identifying Braille symbols depends on the consistency and direction of finger movements. The findings emphasize the importance of movement in processing spatial information through touch. Spatial coding and lateral scanning movements in text reading. The act of scanning text with fingers involves both lateral and vertical movements, which help encode spatial relationships between characters. Studies show that systematic movement patterns improve spatial memory and recall. Errors in spatial tasks often occur when scanning movements are inconsistent or disrupted. Which hand is best? Spatial coding with the left and right hand. The chapter investigates whether the dominant hand is better suited for spatial tasks involving touch and movement. Findings suggest the dominant hand typically performs better in tasks requiring fine motor skills and detailed spatial coding. The non-dominant hand often supports by providing stable reference points or assisting in bimanual tasks. Differences in performance are linked to hemispheric specialization in the brain. Hand movements and spatial reference for larger non-verbal displays. Beyond Braille, hand movements are essential for interpreting larger tactile displays such as maps or diagrams. Exploratory movements provide spatial information about the layout, relationships, and scale of objects in small-scale spaces. Haptic spatial coding and hand effects. A test of two hypotheses. The chapter tests two hypotheses regarding hand movements in haptic spatial coding. First, the redundancy hypothesis. Consistent movements and multiple reference cues enhance spatial accuracy. Second, the discrepancy hypothesis. Misaligned or inconsistent cues lead to errors and spatial distortions. Experimental results support the redundancy hypothesis, showing that combining external and body-centered reference cues improves spatial accuracy. Summary: spatial coding and movement information in haptic perception. Active hand movements are critical for encoding spatial information through touch. Spatial coding relies on integrating inputs from the skin, proprioception, which is the sense of body position, and external reference points. Efficient spatial processing depends on the availability of consistent and redundant reference cues. Key experiments: Braille reading. Accuracy participants read Braille characters using systematic and random scanning movements. Results showed higher accuracy with systematic movements, highlighting the role of movement direction and consistency. Hand performance in spatial tasks. Tests comparing left and right hands revealed that the dominant hand excelled in precision tasks, while the non-dominant hand provided complementary support. Effects of disrupted reference cues. Experiments introduced inconsistencies in external or body-centered reference points. Participants made predictable errors, confirming the importance of aligned reference cues for accurate spatial coding. Practical implications: rehabilitation and accessibility tools. Insights into hand movements and spatial coding can inform the design of tools for individuals with visual impairments, such as tactile maps or Braille displays. Education and training programs for Braille readers and individuals with sensory impairments can emphasize systematic scanning and movement techniques to improve spatial perception. Neuroscience and robotics. Understanding how humans use hand movements for spatial tasks can inspire designs for robotic systems capable of haptic exploration and spatial reasoning. Conclusion. Chapter 4 underscores the importance of hand movements in spatial coding, particularly in touch-based tasks. It highlights how consistent movements and reference cues enhance spatial accuracy while disruptions lead to predictable errors. The findings demonstrate the intricate interplay between motor actions, sensory inputs, and spatial cognition.